My name is Caden Freeman, and this is my informative speech on the engineering in F1. So, the first thing I wanted to talk about is what exactly is Formula One. Well, it is the highest level of motorsport there is with the fastest cars in the world. Just imagine a car speeding down a straight at 200 miles an hour and then only slowing down to 150 to take a corner. That is what it's like to race in Formula One. And some people describe this amazing speed as magic, but many know that it's no magic, it's engineering. So, my name is Caden Freeman, and I'm a mechanical engineering student at Grand Canyon University. And I've been following racing for around 6 years. So I wanted to share what it's like to follow the sport and the engineering that is within it. And I just want to say, like, F1 and the innovations are all around. It's not only in the sport, it's not a little bubble. The innovations that have come from F1 has gone to all over to the cars that we have in the world. So yeah, I just wanted to go over some of the amazing subsystems and the technologies that have come from F1. So let's dive into it. So the first subsystem I wanted to talk about was engines. Engines, this is like the most obvious big subsystem in a car. It's the part that makes screaming noises when passing down in straights. Many people, when they think of F1, they think of screaming V10 engines, but in the modern day, we have turbo V6 hybrid engines. And that sounds like a lot, but really they have these engines to mimic the car industry that we have today. Um, Nobody has a consumer car that's a V10 anymore. So we wanted a more efficient engine that models engines that are in the real world so that technologies can trickle down into the cars that we have today. And one of the coolest part about these engines is the ERS system. And the ERS system is called energy recovery system. And basically, whenever the car brakes, instead of wasting the energy of heat from the brakes, that heat recharges the battery in the car, which makes it go faster. And not only heat from the brakes, but also heat from the engine, which is quite cool. This improves efficiency, and these technologies are around in the real world, like the Prius does it. So it's quite cool how it can be applied. The next I want to talk about is aerodynamics. Aerodynamics is a complicated subject that engineers have been trying to figure out for the last 70 years. And now that we have super high tech programs like fluid dynamic programs, it is really cool what engineers can come up with. Like you can see in the top left, they have like paint that shows the flow of air through the car. And basically, they're trying to like have the most downforce possible for the car. What is downforce? It's the force pushing down on the car from the wings. Because the wing on an F1 car is like an upside down plane wing. Plane makes uh planes go up with their wings, and then if you put the wings upside down, it makes you go down. And that pushing force that pushes you down pushes you in the track, which gives you more grip. And that's what engineers are chasing after is the most efficient wings for an F1 car. But with this comes a lot of responsibility because the cars are getting so much faster. And so they had to design safer cars. And this comes with the monocoque, which you can see in the middle picture. And the monocoque is a carbon fiber chassis. It's one piece. And carbon fiber is an extremely strong material in specific directions that will protect the driver. And you can see on the right, that is actually not a carbon fiber chassis. You can see the frame is steel, and then they built around it, which is less safe. It can like deconstruct and hurt the driver that's in it. So it's quite cool where that technology has come from. And there are monocoque cars in real life too. Um, and for some more real world applications, I wrote down a little list of like innovations that have come through F1 to modern cars. And some of the notable ones that I found was paddle shifters in a lot of sports cars. We have four-wheel drive, ABS, which is anti-lock braking system. We have the CVT's transmission. We have carbon fiber, disc brakes, and even the very idea of aerodynamics in cars came from the world of Formula One. Two that I really wanted to talk about was ABS and disc brakes because I think those are really cool. So on the top right, you see a normal disc brake, and then on the bottom right, you see a drum brake. And all cars used to have drum brakes, but there's a lot of issues with them because it's a whole contraption and very complicated and would cover the whole brake. It's like two big clamps that go around and it would clamp on the brake. The thing is, there was no way for the heat to escape. So the brakes would get too hot and then you get brake fades. So then engineers from F1 came up with the disc brake, which is a little caliper right there that clamps on the brake. And then the rest of the rotor has room to cool going through the air, which is quite cool. Pretty much every single car made, I mean, every single car made right now has disc brakes. So that was a momentous innovation. So yeah, these innovations increase safety, efficiency, and even the speed of modern cars. So in conclusion, we talked about some subsystems like aerodynamics and engines, and we talked about some applications. Um, but why do we care? Well, we care because like next time you're in a car, just look around you and really enjoy the applications of the engineering that came from the sport all around you, because cars would not be the same without it. And as a famous F1 driver, Graham Hill, once said, I'm an artist, the track is my canvas, and my car is my brush. Let's just appreciate the engineers that made this art possible. Thank you. My name is Gavin Freeman.